Now it's time to add sound effects to our game. But before we start to add audio sources, I suggest that you start with a mixer instead. So let's create a new folder, call it mixer. And in our mixer folder, let's create an audio mixer and call it default audio mixer. And then double click. Now we see our mixer here, which just has a master channel. And in groups, we have this plus sign where we can add a new group. So let's add one that is called music and another one that is called SFX. So mixers are great to work with in Unity, but often you set them up too late in a project, which becomes sort of painful because you need to change all your audio sources. But if you already have them as a start, it's much easier. So the benefits with using this is, if you want to have a setting, for instance a music volume, we can change this through code. So if a user decreases the volume in settings, we just decrease the music. And the same with sound effects. So then we don't have to worry about every single audio source being coming too loud or too low. And the user can also set the master volume. So it's an easy way to allow control. And also, if you don't want to change every individual sound effect for the volume, for instance, then we can group them together and call them, let's call them car, for instance, and we can make a sub class here, a class group, and we can call it car. And under these we can just drop in all the different sound effects for the car, and then we can just lower the whole thing or increase the volume. But for now, we're just gonna leave it at the standard sound effects. We can also add some effects like echoes and also different type of reverbs. So you could use this, for instance, if you enter an area where there's a cave and you want to echo, then you can easily add this to just sound effects. Or you can add it to the music at certain parts, for instance, if you want to have a special vibe when you enter an area. And as well for our game here, we can have a lot of different ambience. For instance, if you go through a tunnel, maybe you want to have some echo and some other effects. But for now, we're just gonna leave this as it is, this base here. And then I've added a couple of sound effects. So we have this engine loop that we're going to start with, which sounds like this. So it's just a loop that is an endless loop. And when we are doing loops, it's important that they are true loops without any clips or clicks in them. So if we loop, we should hear that it doesn't say any like chick, chick after, because then it's not a true loop and it's going to sound bad. There are some limitations with loops, and it has to do with if you build for WebGL or HTML5, this file will be converted into an MP3. And if it's an MP3 file, it is going to have a sort of silence before it starts. So that is going to cause it to clip or have these clip sounds. So if you are dealing with HTML5 or WebGL, then this engine loop, you will need to make sure that it's really long and play it once and then restart it after some period of time and hope that the user doesn't notice whenever it clicks. Because if it's clicking like every second here, or more often, users will hear that. But all right, so let's add sound effects to our car, and we'll start with the engine loop here. So in our car base, let's open it up and let's organize it a little bit. So let's create an empty child here, call it SFX, and create another child. And then we have the engine, car engine SFX. And then let's add an audio source. And there we go. And here's the important part, the output here, we need to set it to the mixer group already. So let's click that and set it to SFX. And we want it to play on awake, and we want it to loop. So if we go into our scene view and select our SFX here, we can see that, okay, there is an area around the car here where we can see how big the audio source is, and it's actually huge. So right now the audio source, we have to really zoom out. This is the distance that we can hear it in. And we also have this spatial blend, which is set to 2D. So it's going to be heard no matter where it is in the scene. So instead, let's change that to 3D. And that causes it to care about what position it has in the game world. So the second part that we want to do is change this distance. So our distance is how far away can we hear the car. And right now it's going to be super far. So instead we can have a max distance of maybe 10. And this is still quite far away from the car. But we are not going to drown the user with too many sound effects at the same time. So the car engine sound effects is just going to be played by the car that is the player's car. So let's actually uncheck our play on awake, because we want only a certain type of car, the player's car, to play it. And our min distance is 1, max distance is 10. So that's a okay distance, I think, to start with, and we can check the loudness later on. So let's save our prefab here, and then we are going to add this to our car handler. But before we start, we are going to fix a little bug that we have in our game around restarts. So let's open the input handler in your editor. And I've changed to VS Code. So this is new for me, and I really like it so far. Yeah, I can recommend that you give it a try. It works the same as Visual Studio, but it's a little bit handier, I think. So first of all, let's go through the bug that we have. So as our car is crashing now, we are going into this slow motion mode, and it restores the timescale after a while, but while it's running its slow motion mode, the timescale is going to be, well, something like 0.7. Just picking a random number. It's not going to be 1 anyway. And when we are then hitting the R here to restart, we are just reloading the scene. And we are not resetting the timescale anywhere. So that means that the game will run slower next time that you start it up, until you crash, and then let the whole sort of slow motion effect play out. So instead, we want it to restore the time whenever we're pressing the R to restart the game. So let's add a comment, restore time scale, and then we do time.timescale is equal to, and then 1.0 f. So then we are restoring our timescale. And then let's go into our car handler, and in our car handler we're going to add ability to handle sound effects. So after our explode here, let's add a header so that we're differentiating our code a bit. So header, call it SFX. That will clean up our code a little bit. And then we need a serialized field here. And we need an audio source, and let's call it car engine, AS for audio source. Then let's add another serialized field, and we are going to use an animation curve, and we're going to control the car pitch animation or car pitch with an animation curve. So an animation curve is sort of a curve that you can sort of draw in Unity and then use it inside a function like this. So in our case, we want to have the car's engine pitch change dependent on how fast we're traveling. So the faster we're traveling, the higher pitch we want. So it becomes like okay, you get it. And we can control how this curve is going to change by changing it in Unity instead of writing the whole code for it in here. So it's easier to do it with an animation curve. Then let's go down to our start, and in our start here we are checking if we're the player or not. And as I said before, we only want the car engine to play if we are the player. So in this case, let's because we have already assigned here is player. So what we'll do is we'll make an an if statement is player, and if we are the player, let's do car engine as.play. So in that case, we are going to play our sound effect or the whole engine audio source, and it's going to loop because it's set to loop. Then we need to create a function which we can call in the update function that will change the pitch of the car engine, so it sounds differently depending on how fast we are driving. So let's go down and well, I think here after the steering, let's add it. And first of all, let's make a void update car audio function, and in this function, the first thing that we're going to check, just to make sure that we're sort of not doing anything for AIs that shouldn't have this car audio. So let's check if is not player. So if you're not a player, we're going to guard it against it and say, okay, we're going to return. So if you're an AI, it's going to reach this function and then exit, right? And then we need our pitch here. So the pitch is going to be based on how fast the car is driving, right? So the car has a maximum speed, and that is our maximum for velocity, and it has a current speed, so how fast it's driving right now. And we want to figure out a percentage between 0 and 100, how fast it is right now, because that is what we're going to use for our animation curve to make sure that we are sort of getting the right value. So let's create a float, call it car max speed percentage, and make it equal to, and then we'll take our rigid body velocity in the Z direction, so how fast forward are we going, and we're dividing it with our max forward velocity. So that gives us a normalized percentage between 0 and 1. And then we can use this. So let's take our car engine audio source, change the pitch of it, and set it equal to, and then we'll take our car pitch animation curve, evaluate, and then feed it with a car max speed percentage here. So the evaluate is going to return a value, and it says here evaluate float time. Well, you can see it as a percentage, so we are going to allow it to be between 0 and 1, and that's how we need to set up our animation curve. Then we need to call our update car audio. So let's go into our update function and let's add it to the end. So let's go update car audio. Then we will need another function similar to this one that we use whenever our car explodes and we want the game to stop. Then we need our car engine to stop playing again. And instead of just stopping it right away, we're going to do something special. But let's just add a function, void fade out car audio. So instead of stopping the car engine, we are going to reduce the volume. By reducing the volume, we can avoid clipping and other nasty sounds, and it will be more natural for the player. So let's start our function. And the first thing, same as we did here, we're going to check if we are a player. If we're not, let's return. Then the second part is our volume. So we'll take our volume, car engine as.volume, and we want to fade it over time. So we'll use a math f lerp and then feed it with a car engine as.volume. So the current volume, whatever it is, and we want it to go to 0. And we want this to happen over time. So let's use time delta time, and then let's multiply that by 10. So it goes fairly quickly down to 0. Then we will need to call this function. So let's copy our function here, the name of the function. And it is the place that where we can call this or should call this is after we have exploded. So if we are exploded, then let's do a return as we did before. But we are, even when we're exploded, this part of the code is going to execute. So let's bring in our code here. And obviously I didn't copy it. Well, I did. Well, there we go. Fade out car audio. So this is going to happen when we're exploded, and it's going to return, so it's going to stop this from running. And it's only going to happen on player cars. So let's save that and go back into Unity and try it out. So let's assign our car engine AS here in our car handler. So drag and drop it in there. And then we have our car pitch animation curve. So let's click that. And our animation curve is going to go through from 0 until 1. So let's just click to get a default curve in here. And we are going to make it even higher than 1. So our pitch is going to start at, I think 0.5 will be a better starting point. And because we don't want it to go to 0, because, well, if it's going really, really slow, we still want it to sound like a car engine and not just do. All right, you get it. But then we want the engine to go up in the pitch. Let's grab that one. And we want it to go fairly loud or high in the pitch. So let's try with maybe a 5. And there we go. Something like that. And we can also change how aggressive our curve is going to be. So let's have it go a little bit faster in the beginning. So I think something like that. And then fade out over time. So we have a bigger change in the beginning and a smaller change towards the end. So at 0.5, which is like halfway, it's going to be higher than well, this first part. So let's try it out, and this is of course something you can adapt and add more points to if you want it to be a specific way of handling the pitch. But this is a nice way of working with things like that. So now we see in our car pitch animation curve that we have. Then let's make sure that our car engine SFX has an audio clip on it, and I forgot to assign it. So let's find our car engine loop and assign it. Okay, so now we can save it and try it in Unity and see what happens. Alright, so now we can hear our car engine, and we can have a look at the pitch here, and it's going down, and now it's going above 3. And if we hit something, it fades away, and if we hit R, restart, it restarts, and the time scale is back to normal. With the newly added sound effects, it does sound more like a game, and there are a few more improvements we can do. So let's take our car engine SFX here and let's duplicate it. And one thing is when we are braking, and when we are at least going fast and braking, then we want some sort of skid sound effects to be played, and we don't want that to loop. And instead of using our engine loop, we're going to use tire skid here. So the tire skid, if we listen to it, it's sort of a sound that goes like this. And our skid is probably not going to be this long, so it's important that the length of our skid here is long enough to handle the whole skidding period. So if it skids for 5 seconds, then it's going to have to repeat, and that sounds bad. So in that case, you have to manipulate the sound so it becomes a little bit longer. So let's make sure that we have our tire skid set here, and our pitch is 1, and similar to as before, we don't want it to be play on awake, because we only want it to be played by the player and at certain periods of time when we are braking enough. So let's save our car here so I don't forget it, and let's go back into our car handler. So in our car handler, after our engine AS here, let's add a new we're going to add a new serialized field. So we get serialized field, and in it let's put an audio source, and it's going to be skid AS, so the same abbreviation as before, audio source. So this skid audio source, let's update that and play it in our new function here, update car audio. So after we have evaluated our engine pitch, let's add our skidding. And as I said before, we don't want the skid to be played at all times, so we need to limit whenever it is going to be played. So let's do an if condition. And first of all, we want to skid whenever the player is sort of pressing the brakes, right? So if input Y is less than 0. So as soon as we would press sort of the accelerator brake here, it would play the sound, which sounds a little bit weird because maybe we're not going that fast. So let's check our car max speed percentage here. So if our car max speed percentage is larger than 0.2, in that case we are going to play it. So we need to make sure that it's not already playing. So let's check if car skid AS is not playing. So if it's not playing, then it means that it's time to actually play it. So let's go car skid AS and play. And then we want to adjust the volume of our car skidding here, because we don't want it to be the same all the time. We want it to feel like if we're going fast, then the skidding is going to be loud. If we're going slow, it's not going to be that loud. So let's adjust the volume. Car skid as.volume is equal to, and then we'll do it the same way as we did with the fade. Let's lerp it, and we'll lerp the car skid volume, and we want it to go to 1 as the maximum value, and we'll do it over time delta time as before, and we'll multiply it by 10, so it goes fairly quickly when it goes when it increases. And if we are not hitting our sort of brake button, or if we're going too slow, then we need to fade our car skid, fade out the volume, because we don't want it to play the whole clip, right? So in that case, let's add else, and then car skid volume, and we'll do a reversed fade. So let's do a math f lerp with the volume to 0, and in this case let's do it a little bit faster even than before. So whenever we are stopping, it's going to be super fast, but without using our car skid dot stop, because that is going to sort of clip, or can clip. It can sound like a chick whenever you're doing that. So let's avoid doing it that way. And same as before in our car skid volume here, because we have used that, we need to go into our fade here, because we could crash while we're sort of skidding here, and in that case it wouldn't do this update anymore because we have exploded. In that case, let's do our car skid AS volume, and I managed to add a space there, is equal, and then we'll do a lerp skid volume to 0 with time delta time times and 10. So let's try that out and see how our car skidding sounds like. So let's save and go back into Unity. So make sure that we have our tire skid here, and SFX, no, our car here needs to have our audio source in its slot in there. So car skid AS, let's drag and drop it in there. Save, go back into Unity and try it out. Alright, so let's accelerate and then brake. And that was a short. So let's try to go faster. Yeah, baby, that sounds good. So now we have our skidding, which is cool. But I mean, it's still quite underwhelming when we are crashing, right? There's no thing going on. So we need to add some more sound effects to make this more interesting. So let's go back in our car handler here, and let's add another audio source. So again, let's go serialize field, audio source, and call it car crash AS. So our car crash AS is going to be some loud noise that happens whenever we are crashing. So when are we crashing? Well, we have our own collision enter right here. So our car crashing, we wanted to make it a little bit more interesting, and we don't want it to sound the same all the time, and we also want the AI to play this. So this is going to be more noise in our sort of game, but it's cool whenever we are seeing the AI explode that, well, we have some sound effects on it. So the first thing that we need to adapt is our volume, right? So our volume of the car crash should be based on how fast we're traveling. So we had our float car max speed percentage here. So this is a quite good variable to use in the case down here as well. So let's make this into a global variable for this function, or for this class. So hold on, need to copy it and delete our float here and just move it up. So max values, input, let's add actually it's a max value, it's similar to this one, so let's just add it under there, and it's going to be 0 as a start. So now where were we? Here we are. So we wanted the volume to be adapted to how fast we are traveling. So our crash volume, let's take our car crash ES volume equal to, and then car max speed percentage. So that is going to be a value between 0 and 1, right? So the faster you're traveling, the higher explosion. And if you're going really slow, we still want an explosion, right? So we need to do something that it's going to be played anyway. So let's do a car crash volume, and we'll do a mathf.clamp and then add the volume. So this is the variable that we're clamping, and it's going to be clamped between 0.25, so the lowest potential value is going to be 0.25, and 1. So it's going to be somewhere in between those values. And then our pitch, we want to adapt that as well. So the sort of higher the speed, the higher the pitch. So let's do a car crash pitch and equal to, and car max speed percentage, and then car crash AS pitch is equal to, and then you guessed it, we're gonna clamp it. So let's clamp our value here, and we'll clamp it at 0.3. Below that it sounds a little bit too weird, so let's clamp it to 0.3 and 1. And then of course we need to play our car crash AS, and we don't have to really care if it's already playing, because we have our on collision enter is only going to be happening once. After it's happened, the collisions are disabled anyway, so it can only happen once. Okay, so now we have our car crash, so let's save and go back into Unity and try it. So again, let's duplicate our Skid SFX here. Oops, I was not in the prefab. So let's go in the prefab and do it from there. And then we have our crash, and change it to our crash. And it sounds like this. And in our crash here, because now it's set to 10, right? So the max distance is 10, and maybe we want it to be a little bit longer so we can hear something happening over here. So let's put it to max distance 20. And the special blend is 3D, so that's perfect. And then we need to assign it as well. Car crash. There we go. Hit save and hit play. Okay, so let's hit something. Yeah. So that was a quite cool effect. But we have all these parts, so maybe we can do something even cooler with the parts, right? So if we hit another car here, so now we have these parts flying, and it would be cool if these parts are making sound effects, right? Whenever they're hitting something, we want them as well to sort of, yeah, make some kind of noise, because that would be cool and fun for the player. So to do that, we will create a new script. So let's go into scripts, explode, and create a new C# script, call it car part handler, and open that in your editor. Now our car part handler here, it's going to sit on every single piece that is exploding. So they are all rigid body when they're exploding, which means that we can react to their events, so they're on collision events. So the first thing we need is an audio source. So instead of assigning it through the editor, through the inspector, we're going to assume that the audio source is attached to this object. So, and we'll call it bounce AS. So first of all, we need to get our bounce, right? So we'll do that as we have done with other components. So let's do a, oops, I'm at the wrong place here, void awake, and then in our void, let's do bounce AS is equal to, and then get component audio source, and then close the brackets. And the second part is that we're going to react to our collision, right? So we have a void on collision enter, collision, and our call it collision. So this will happen whenever the wheel bounces. So, and we need to check this bounce AS. If it's already playing, then or if it's not already playing, then let's play it. So as well, to make it more interesting, let's change the pitch so it doesn't sound the same for every object, because there's going to be a lot of objects exploding, and it's sort of boring when they sound exactly the same. So one easy way of changing this is by changing the pitch. You could have multiple audio sources with or multiple clips as well, but let's just change the pitch. So we'll take in our collision relative velocity dot magnitude. So the relative velocity is the difference between the two colliding objects, right? And the magnitude is just going to be a sum of this vector, so the length of the vector, and then we'll multiply it by 0.5. And we need to make sure that it doesn't get out of hand, so let's clamp it, and we'll clamp it between we'll take the pitch 0.5 and 1, so it can't go beyond those values, below or beyond. And if we're not playing, then let's play it. And then we are done with that, and we can close our brackets. So let's save that and go back into Unity. Then let's go into our car base prefab here, and let's copy our car crash. And then when I think about it, let's copy just the audio source. And then we have all these different parts, right? These are the parts that are going to come flying off whenever we are hitting something. So let's just paste component as new. And instead of having our car collision here, let's use our bounce. And our bounce sounds like this. So that's a basketball bouncing. And well, if I didn't say that before, the sound effects are from freesound.org, and there are CC0 sound effects, so you can use them in your projects. And then we need our script, right? So we put it in car part handler. Here we go, and let's bring it in there. And we don't need to assign this audio source because it's already well, it's getting it by itself. And then let's just check spatial blend, and the range is 20. Yeah, I think that would be good. And let's save it. And yeah, let's try it. So let's just quickly hit something. And there we have it. a variation of it. So let's go a little bit faster. Yay. Yeah, that's quite cool. That's a lot better. So now we have our skidding, we have our explosion, and yeah, we can just keep adding more cool sound effects. So let's add something to the AI cars, maybe like a car horn. So whenever we are going in front of them, they have to brake. Maybe they get upset because of it. So let's add sound effects for that. So let's take our car crash, duplicate it, call it horn. And I did find a car horn, called it long, and it sounds like this. Yeah, that's a horn. And one thing that we can do with this is we can change the Doppler level. So the Doppler level or the Doppler effect is whenever you're sort of driving past something, you will have like a sound going like, and the same if you hear an ambulance in the distance. It sounds a little bit different depending on which direction it's going in, and that's the Doppler effect. So we can increase how much our Doppler effect is going to be adjusted. So let's put it out through 3 is maybe a lot. 2. Well, you can fiddle with this on your own, and that would make it sound different depending on how fast we are traveling in relationship to the AI car. So our AI car is going to handle this, right? So our AI car is going to use this horn. So let's open it in our AI handler. So the first thing we'll need is our sound effect. So after our serialized field, let's add it. So we'll add another header just to clean up our code a bit, and then serialized field and audio source, and we call it honk horn or AS. In our code, we already have the ability to detect if another car is ahead of us, but we could be really far away and it would still detect us. I don't remember what to set the raycast to. Well, direction, where are we? Max distance 2. Well, okay, that wasn't very far actually. So anyways, maybe you have a larger value here, so it could be good that we extend our car ahead with a distance. So let's add a float, car ahead distance and equal to 0. So right now we need to figure out, okay, when are we close enough, right? So we are doing our check here. So in our check, we have the number of hits is bigger than 0. So car ahead distance is going to be our transform dot position minus, and then we'll take our raycast hits here, and it's an array, but let's pick the first one because we have a hit and we're going to react to the first one. So and then we have point, right, which is in world space, and if we want a distance from this, let's do magnitude. So now we have our car ahead distance after we have checked for this. Now we want to check here if car is ahead. Then let's extend this. So now we already know that our checking is just 2 units ahead of it, which wasn't a lot, but maybe it's more. So let's check anyway, whatever value you might have. So let's do an if car ahead distance is less than 10, right? And our home horn is not playing. So that means, okay, we're not playing. Then we can play it. And as well with sort of our crashing parts, there could be multiple AIs that are honking at each other and other things, so we want to change the pitch a little bit to make it sound more interesting. So let's change our pitch, and in this case we are going to use a random range between 0.5 and 1.1. So each time the car honks, it's going to have a different horn, but nobody will notice anyway. You won't remember that, oh, that specific car is sounding different now. So let's just use random. You could randomize it once and then leave it, but we're going to keep it simple. So, and then we need to play it, right? And close the function. So now we've added our honk horn. So let's save that and go back into Unity. And then let's assign our horn to our honk horn AS. Save it and then try it. So let's try fast. And we need an AI car. Yeah, and as you heard, we had that pitch change, right? So if you drive fast and maybe not crash into it. See, there we had that Doppler effect. And we can crash. Yeah, that's cool. Yes, and they are keeping, they're honking at each other. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching and don't forget to like and subscribe. I'll see you in the next video.